Yes. Fazila, now I'm asking Jacqueline what each one of these lines is telling you.
It's telling you what each person and what department that they're working in. I don't know what the end part means with the equal one comma.
Good. And Jacqueline wants to know, and she has you to tell her. Can you tell her? Kwaku.
Yeah. I think the equal one just means because like it's like the total, like the end, so it's all equal to one after you add
And
everything up.
I'm going to say something. When we have equal one in Mathematica, we don't have only one equal, we have two equals. We have one equal, two equals. And then we put a space, and the two equals are connected to give you equality for Mathematica. Or you can be able to have a different case. You can be able to have greater or equal to 1, and you can have inequality. And what I would like to know is what is the difference between equality or inequality? What is the difference between this case and the other case? Isabel.
Is it? You said when it's a negative, it's a supply that was it's the supply that you have to use or that you did use.
You are close. Let's focus a little bit. Now I underline the first line, what this says in plain English. Now I want you to translate from Arabic to English.
There's four departments and there's four nurse. Oh, and there's one nurse.
Yeah.
So it's showing you the one nurse that is available to work in four different departments.
Good. In other words, I can teach decisions, I can teach calculus, I can teach statistics, I can teach management. I cannot teach, and I don't want to teach marketing, I don't want to teach human resources, etc. Where do I go? And this says that each one of them is available to go. Where? Where?
To one particular department.
In other words, if one goes to one department, doesn't go to any other department. And if I have four nurses in four departments, the same thing is true here. The first line here says what? That's Kovani.
It's saying that all the four nurses are going to urology.
Correct. In other words, the urology department can take any of the four nurses. In one case, we have the supply of nurses. And the other case, we have the demand from the departments. If all the departments need one nurse, and if each nurse can work only to one department, then we can be able to have a decision. How do we make a decision? Based upon the performance score. What is the performance score? In this case, the lowest means better fit. The highest means the worst fit. Because of that, we want to have the minimum case overall. Do we have a balanced case? Esther?
Yes, Professor.
We have 4 nurses and 4 departments. That's a balanced case. What these inequalities mean? Jerry, in class you don't talk to anyone else except if you tell me and give you a permission. If it's work-related matter and you have to talk, I don't have a problem. Jerry, what these things mean?
Understood, Professor.
I know, man. That's why we have good relations. What these inequalities mean, that they are positive.
Give me a second.
I'll give you 2 seconds.
Well, I don't understand the inequality, but it shows the every other nurse
Anyone can help him.
showing the nurse with the
Anyone can help him.
Professor, can I try?
Yeah.
But, okay. So it's showing an index of 0. That means that the nurse will be suited perfectly in any task.
Good. And what did I ask you? Do you trust people or not? What did I say? Do you trust people or not? Esther said something. Do I take her advice or not? Esther, do you want to test yourself? And I test myself only when I solve the problem. How do I solve the problem? I go anywhere here, I put shift enter, and the problem is solved. I have here the solution of the problem. I take the solution of the problem. This is the solution of the problem. It says that different nurses are allocated to different places. And the overall satisfaction is 86. If I want to take that case, I'm going to compare it with the other problem, the maximum problem. The maximum problem gives me a different solution. And if I take these 2 different solutions, I want to see one versus the other. And I want to see where everyone goes. One is the best case, the other is the worst case. And I want to see what is happening. I take the best case. I go to the end and I put it here. I take the worst case. I take the worst case and I put it there. I mark it. This is the best. Green. This is the worst. Red. This is the outcome. I want to play around. I'll make it a text. This is the outcome. I want to play around. I make it a text. And I want to see what is happening. I see what is going on to urology. I see what is going on to urology. I see what is going on to cardiology. I see what is going on to orthopedics, and I see what is going on to pediatrics. Same thing here. I see what is going on to urology. I see what is going on to cardiology. I see what is going on to orthopedics, and I see what is going on to pediatrics. What is my solution? Cook is allocated to urology. Morris is allocated to cardiology. Richard is allocated to orthopedics. And Morgan is allocated to pediatrics. Every department gets a nurse. The worst case, Morgan goes to urology. Richards goes to cardiology. Cook goes to orthopedics. And Morris goes to pediatrics. The worst versus the best allocation, correct? And we have a specific situation. Morris is my friend. If Morris goes with what she can be able to perform the best, she is allocated to cardiology. But cardiology is a very busy department. And she does not want to be in cardiology. I mark it. She is there, but she doesn't want to be there. Like me, I don't want to teach this class. Why don't I want to teach this class? Robert.
Honestly, I don't know. I mean, you're talented. Basically, this problem is where you put the best talent, the talent to get the most out of them, and you have to fill all
I
the
deal with
disciplines.
that for the last 30 years, and I have read every book, and I know everyone, but it is taking a lot of time.
Yeah.
And you don't know who is going to be in your class. This summer, I like it. Last spring, I hated. I had people in class that they were coming to go on and not pay attention to what is happening. And since I don't know who is going to be in the classroom, I don't want to teach it. What do I want to teach? Something else that's going to be more fun and much easier.
I get it.
Morrison is placed in her worst performance. She will be in pediatrics. But in pediatrics, things are easy sometimes, but you don't want to see small kids being with problems. Let's assume that urology is an easier way to deal with. And let's assume that Morris, what happened? Robert, what happened?
Oh, that big thunderbolt.
Okay, that's the weather. And let's assume that Moritz has an advantage from everybody else. Let's assume Esther is making the schedule. Esther is making the schedule. And Morris says to Esther, Esther, I don't want to be in cardiology. The easiest way to do is to be in urology. But you put Cook in urology. And I want to be in urology. The worst case is Morgan in urology, but Morris wants to be in urology. And Esther is making the schedule. And Morris is a friend with Esther. Can Morris go to the code and make something that Morris is going to go to urology? Esther, the question is for you. Can you do something that you can put Morris to urology? And if I ask you why you did it, and if Robert asks you why you did it, you will say, I didn't do it, the computer did it. Can you make any change here that you can be able to place Morris in urology? You cannot touch this data. This is objective information. Morris in urology is really good, but you solve it and you don't put Morris in urology. You solve it and you don't put Morris in urology, you put her in cardiology. Can you do something that you will have an excuse to put Morris in urology and not Morris in cardiology? Morris is good in cardiology, but she is better in urology. Her work is better in urology. It's not as stressful as in cardiology. And she is your friend. And you cover your back to say, okay, I'll put Morris in urology. And if you do that, you go on to the problem here. Who is in urology? Cook. And Cook is going to come and say, why did you take me out of urology? And you say, the program did it. But I took you out of urology because Morris is better in urology. But you're not that good in urology. Can you do the problem in the program that whenever you solve it, the solution here is going to have Morris in urology and not Morris in cardiology. The solution says Morris in cardiology. Can you make Morris to be in urology?
Professor.
No, sir. Let's.
You could create an equality and then assign everybody else thereafter.
Or create a condition with a range. I don't know, something.
So, what do you think here? Morris
Can I-
in urology can be or not be there. You change it. And you put one. This is the question I asked before to Esther. That's why I want her to give the case. What did I do here? I changed one requirement. What is that particular change? I changed this requirement. Now I require Morris to be in urology. Do I have information to back up my decision? Yeah, Morris is the best in urology, but she's not allocated there. Who is allocated in urology? Cook is allocated in urology. She's also good, but she's not the best. If I take it, I make the change, and I solve the problem, what do I get? I get an altered solution. And that altered solution, it is here. I want to look at it. I'm turning it to a text. I'm giving it a different color. I'm gonna put it crayon because I fixed it. And I want to see what is happening. In urology, Morris goes to urology. But if Morris goes to urology, we have domino effect. And what is happening? Cook goes to cardiology. Richards goes to orthopedics. And Morgan goes to pediatrics. Things are reshaped. Why? Because the person who was in charge of the schedule put the condition to have that done. Put the condition. What is the condition? What is the condition? We change the case here. We change the case here. What this means? That Morris should go to cardiology. Is this clear?
Yeah.
As long as we have evidence to defend the case, we can be able to make that case. And then I want you to do some homework right now, and I'm gonna give you some time. Erica and who doesn't have it? Jacqueline can work in a team with someone else. Pick up your team. Who else doesn't have a computer in front of you? Pick up a teammate. And I want to go on and make some changes. I want you to change the problem. What is this problem? The problem is balanced. You have 4 nurses, and there are in 4 different departments. And each department needs at least 1 nurse. I want to make it unbalanced. And if you want to make it unbalanced, I want to have a nurse that can go to more than 1 department. So let's say, who is the best nurse? Who is the best nurse? You find it from here. Morris and Cooks are better nurse. You get it from the numbers you had before, looking at averages and standard deviations. And if you have that case, you may say that Morris can go to at least 3 departments. And Richard can go to 2 departments. Now, what is the availability of the nurses? How many nurses want to go on to particular departments? What is the total number?
7.
7. But let me go here. But the Department of Orthopedics cannot take more than 3, and the Department of Cardiology cannot take more than 2. Let's put it 2 here. Now, what kind of a problem do we have? Balanced or unbalanced?
Imbalanced?
We don't have a balanced problem. What is the problem that we have? Morris wants to go to 3 departments, but no department wants to have 3 nurses. How do you allocate everything? That means that Morris cannot go to 3 departments, can go only to 1 department. What did we do here? We put at least to urology Morris. We correct that part. We solve the problem again. Do we get a solution? Do we get a solution?
No.
Do we get a solution? You go back to your notes, and you look at your notes, what do you need to do? When you want to have minimization, what do you need? Greater than equal or less than equal cases?
Less than
Less
equal.
than equal.
So, can you put things in a different order? And you change the problem in such a way that we can have it as it is. and why I don't get a solution. That goes beyond what I can do with you within 1 month. But this is what actually you have to deal with because that's the case. We can play around and we see, do we have a solution? Now, did we solve the problem? Is a solution now to the problem?
Yes, there is one.
What is the solution? I take it and I bring it back that I have all the solutions. This is my new solution. I go on and I can see that's a new solution. I want to see it as text and I want to see what is happening with that solution. I go on to urology. Cook goes to urology. I go on to cardiology. Nobody goes to cardiology. I go on to orthopedics. Nobody goes to orthopedics. I go on to pediatrics. Only one nurse goes here and another nurse goes there. The problem is solved. Are you happy with the answer? Are you happy with the answer?
I am not happy.
Don't be happy. Because only 2 people go to 2 departments and you want to have more cases. So what I want you to do is I want you on your own later on, whatever is happening, to be able to deal with these cases. But now I want you to be focused on mainly one thing. Stop presenting you and I want to say what do I